Hello. Yeah. So we are live friends. So today's agenda is to solve as much as problem in the PDSA. So we are live friends. Today's agenda I am aiming for kind of getting 100. So I am aiming for getting a full marks in the PDSA too. Mm, maybe it sounds like I am quite overconfident, right? But it's not. The problem is uh, I understand the algorithm, what's going on in the algorithm quite well, and I could manually figure out what the algorithm is trying to say. But when it comes to write the code and translate our thought process to the code, then in that case I fumbled up like nothing. So we will try to understand each and every code. What the question is there, how to approach that problem, and at last how to translate the problem into the code. So I will try to solve all these questions given here only, given in the live coding session. Maybe while solving the question, I will not be able to make you understand what's the logical process. But what I will try to do is I will go through the question, try to figure out which concept it is related with. Then we will jump into certain documentation that could help, or a video if that would suffice, and then we will try to solve it by ourselves. We will try for some time, and then if we aren't able to solve at all, then at last we will see the solution and solve this question. And later on I will try to revisit this question again and again, so that it kind of stuck in my head, and that's the process I will try which is my PDSA exam date. So it's my improvement subject, right? Earlier I have taken this subject, but the problem was I have in last year in the January term I take subject, and it at that time I don't have enough knowledge about what's going on. Means everything was new for me, and I am not been able to cope up with the four subjects, as well as maintaining a dual degree, right? Going to the college every day, maintaining a 25% attendance. So I fumbled up very badly, and then I take for an improvement in this term. So let's try to solve as much as question we could in the stream. Let's go. Yeah, so what I understand from this question is that, so given there is an adjacency list, and in this list the different different trains are given, and their routes are given in this list, right? Like for example, we could see in the for the train one will go through, let's say, the platforms, or yeah, let's say for platform 3 to 5 and then 8. So the idea is, we will be given a starting point and an ending point, and then we have to figure out, like, how many changes, or yeah, how many changes we have to make. Not how many changes, but we have to figure out the route through which we could reach from starting vertex to the ending vertex, and that should be done in the minimum number of hops, right? So mm, what could be the possible solution of this question? Mm. So as we could see that the graph that is given is an unweighted graph, right? And to find the shortest path in an unweighted graph, there is a way that is there is an algorithm, right? The BFS traversal. So the BFS traversal gives the shortest possible path from a given node to another node, and we have to maintain the route. That is, have a we should have a data structure where we could store from, like, which node we have visited to reach the final end, right? And even in the code that is provided, we could see that there is some kind of BFS fast list, which is kind of indicating that we have to use the BFS traversal. And so let's try to figure out further.
So one of the important things that we want to know about a graph, remember that a graph is not something that we can see. So if we see this graph, these 6 vertices on the right, 2, 3, 6, 7, 10, and in this case 5, right? And then I will explore. So what else can we do? So the way to explore this using BFS is to observe that if I start with BFS and I record the edges that I use for BFS. Remember, when I use BFS, when I find an unvisited neighbor, I add it to the queue and I record this parent thing. So in some sense, I'm recording this edge from J to K was used in BFS. So these used edges actually will form a tree because I will never come back to a node which I have already seen. Right? So BFS guarantees that I will never add an edge to a vertex which has already